Welcome to the video on answers to questions for revision, class 12 mathematics. At this video, answers to questions comprising MCQ, assertion and reasoning, short answer, very short answer, long answer, and case study questions from topic continuity and differentiability is compiled. Question number 1. The function f of x is equal to cot x is discontinuous on the set. We have to identify the set at which f of x is equal to cot x is discontinuous. Now let us recollect the condition for continuity. A function is continuous where it is defined and it is discontinuous at points where it is not defined. Well, let us see where cot x is not defined. Now what is cot x? It is cos x by sin x. Cot x is not defined when sin x goes to 0. Therefore, it is not defined at point for which sin x is 0. Sin x is 0 for x, all x is equal to multiples of pi, 0, pi, 2 pi and so on. Therefore, the option is A. Question number 2. The value of k for which the function is continuous at x is equal to 0. Let us recollect the condition for continuity. If a function is continuous, then the limit x goes to 0, f of x is equal to f of 0. The left hand side limit should exist. What is the meaning of exist? Right limit is equal to left limit. For limit x goes to 0 plus is same as limit x goes to 0 minus is equal to f of 0. Now here we have to see that x goes to 0 plus means x greater than 0. X goes to 0 minus means x is less than 0. Accordingly, you have to select the function. Therefore, for x greater than 0, it is 3. For x less than 0, it is kx by mod x. But what is mod x? Mod x will be minus x when x is less than 0. Accordingly, I have put kx by minus x. Now, when you simplify it, you will get k is equal to minus 3. Therefore, B is the correct answer. Question number 3. You have to find the value of k for which the function is differentiable. Let us recollect the condition for differentiability. Limit h goes to 0, f of a plus h minus f of a by h. Here a is equal to 0. We have to check the right limit and we have to check the left limit. For the right limit, it is h square. For left limit, it is kh. For we are substituting them. For we are getting k is equal to 0. Question number 4. If tan of x plus y by x minus y is equal to k, and dy by dx is equal to. In this, you should be a bit careful. This is a one mark question. Therefore, don't try to do the differentiation directly. Therefore, we have to start by writing tan of x plus y by x minus y is equal to k. Therefore, x plus y by x minus y is equal to tan inverse k. Now, the right hand side has become a constant. Now, start differentiation. We have to use the quotient rule. Now, I am using quotient rule and I am simplifying it. And I am checking out what is dy by dx by collecting all dy by dx to one side. And when you push everything to other side, you are getting the answer as y by x, 2y by 2x. Therefore, it is y by x. Therefore, the option is B. When you do it directly, you may not get the answer, but you have to use this technique. Question number 5. If y square multiplied by 2 minus x is x cube, then you have to find the value of the derivative at 1, 1. Now, I am taking the function now. Now, I am getting y square. I am getting y square is equal to x cube by 2 minus x. You can do it directly also. But when you take log on both sides, the differentiation will become simple. Therefore, we are taking log on both sides and we are doing the differentiation. Be careful with the differentiation of log y. It is 1 by y into dy by dx. We find the dy by dx now. No need to simplify it further because we are going to find the value of dy by dx at 1, 1 directly substitute. Don't take LCM and simplify. And you will get the answer as 2. Option A is correct. Let us move on to assertion and reasoning. Assertion is given, reason is given. First, we have to check whether the assertion is true. Sin inverse x plus cos inverse x plus 2. Now all of you know what is sine inverse x plus cos inverse x. It is pi by 2. Therefore f of x is pi by 2 plus 2. For f dash of x is 0. Therefore f dash of 2 is equal to 0. F of x is a constant function. Now therefore assertion is true. Let us go to the reason now. It is given that derivative of cos x is minus sin x. It is true. But this is not used to prove the assertion. Therefore, the option is B. Both A and R are true, but R is not the correct explanation of A. Go back to question number 7. Assertion is given as y is equal to sin x plus cos x the whole square. Then the derivative of at x is equal to pi is 2. Now let us try to differentiate it. Normal differentiation. Then we are simplifying it and keeping it ready. And then we are substituting. No need to write cos square x minus sin square x as cos 2x. You can directly substitute. Now we are getting the answer as 2 into 1 minus 0. Therefore, it is 2. Because cos pi is minus 1. For you got the assertion as true. But the reason cos square x minus sin square is cos 2x, not sin 2x. Therefore, reason is false. Therefore, you have to tell the option as A is true, but R is false. Go to question number 8. We have to once again we have to find the value of k for which it is continuous. Now we know that the continuity condition limit x goes to 0, f of x should be f of 0. Let us substitute now. Now this 1 minus cos kx to be converted. Now you know the formula 1 minus cos 2x is 2 sin square x. Therefore 1 minus cos kx is 2 sin square kx by 2. Now we are continuing the substitution. But here we are having, when there is a sin square, denominator should be x square. Therefore we are multiplying and dividing by x. When I multiply and divide by x, I can split the limit into two. First limit is sin square kx by 2 by x square. Second is x by sin x. Once again, here it is kx by 2. Our denominator also should be kx by 2 the whole square. For multiplying and dividing by 4 by k square. Now we got two standard limits. Then check out how the constant is coming out. That is very important. For two standard limits are there. Therefore, both the values are 1. Therefore, you are getting the value of k square is equal to 1. Therefore, k is equal to plus or minus 1. You should be strong with the standard limits so that this problem can be done quickly. Okay, y is equal to x power 1 by x. Then you have to find dy by dx. Now, this can be done only by function power function. Therefore, take log on both sides. So, I am taking log 1 by y into dy by dx is equal to, on the right hand side, we have to use product rule. Then after the product rule is done, we have to take LCM. Then you have to multiply by y. Then dy by dx is x power 1 by x into 1 minus log x upon x square. Now they want the value of this derivative at x is equal to 1. Substitute. Log 1 is 0. Therefore, final answer is 1. If y is equal to tan x plus secant x, prove that d square y by dx square is cos x by 1 minus sin the whole square. When you do it directly, you may not get the answer. Therefore, you should be a little bit careful. After the first derivative, simplify and convert it in terms of sin and cos, then continue. Let us see. Y is tan x plus secant x. You know the derivatives. Secant square plus secant x tan x. Take convert everything in terms of sin and cos. Take LCM. You will get 1 plus sin x by cos square. Now what is cos square? 1 minus sin square. It will get cancelled. Therefore, you are getting dy by dx as 1 upon 1 minus sin x. If you don't simplify it, if you do the derivative directly, you may not get the required answer. So this is 1 minus sin x the whole power minus 1. You know the differentiation, minus 1 into whole power minus 2. Then you are getting the final answer as cos x upon 1 minus sin x the whole square. Go to question number 11. If x is equal to e power cos 2t, y is equal to e power sin 2t, prove that. This is a problem of parametric differentiation. Let us find d first dy by dt. Now I am taking log on both sides so that it will be easy for me to do the differentiation. Therefore, now I am taking log y is equal to sin 2t and log x is equal to cos 2t. Then you know that what is sin square 2t plus cos square 2t is 1. Or you are getting log x the whole square plus log y the whole square is equal to 1. You do the differentiation. then you will get the answer as dy by dx is equal to minus y log x by x log y. Okay, now all of you can have a confusion that, sir, can I do it directly also? That is finding dy by dt, then dx by dt. Then you can do it, but that may be little bit lengthier than this. Therefore, we are finding what is x, what is y. And as x and y are sine and cos, we are using the idea that sine square plus cos square is equal to 1. Go to question number 12. If x into root 1 plus y into root 1 plus x is equal to 0, then dy by dx. Now in that case, we am first let me find what is y. Therefore, for that, I am pushing it to the right hand side. I am finding to get the value of y, I am squaring both sides. Whenever there is a square root is there, we can avoid the differentiation by squaring both sides. And then I am getting this equation. Then I am substituting for x square minus y square as x plus y into x minus y. Take x minus y outside. Then x plus y is equal to 0. All of you know that. Because x is not equal to y, therefore x minus y is not equal to 0. Therefore x plus y plus xy is equal to 0. Now you do the differentiation now. It is very easy now. I got the value of y as minus x by 1 plus x. Even though it looks like a problem of implicit function, but it is actually explicit function now. Now use the quotient rule and you will get the answer. Next question, y is equal to log of root x plus 1 by root x the whole square. Then we have to prove this. This is a problem of successive differentiation. Now normal differentiation I am doing and apply the idea of log. Log m by n is log m minus log n. And we are maximum simplification we are doing for y before we start the differentiation. Now do the differentiation, both are log, it is very easy. Now simplify it. You got the first derivative as x minus 1 upon x into x plus 1. Do the second derivative using quotient rule, and second derivative is done using the quotient rule. Again simplification is done so that we can use prove that the given equation. Now second derivative is again simplified. It is coming like this. Now these are the first derivative and second derivative, but they want to prove that this expression is equal to 2. Now substitute. Now normal simplifications. When you do the simplifications, you are getting the final answer as 2. 2x by x, which is equal to 2. Therefore, we have proved the given expression involving second derivative and first derivative. Go to question number 14. This is a problem of parametric differentiation once again. But see the question very carefully. They want d square x by dt square, d square y by dt square, and d square y by dx square. Second derivatives, 3 second derivatives they ask. Okay, well, let us try. X is given. I am finding dx by dt. I am simplifying it so that I can go to the second derivative. I am doing the second derivative with respect to t. Be careful. Therefore, this is the second derivative of x with respect to t. Then y is given. I am finding the first derivative. Simplify it. Then go to the second derivative. Then we found dx by dt and dy by dt. You know the formula for dy by dx. It is dy by dt upon dx by dt. I have put it. Again, simplify it. Go to the second derivative. Now, be careful with the formula of second derivative. Second derivative formula is derivative of this dy by dx with respect to t multiplied by dt by dx. Don't do that second derivative directly, okay? Because left hand side you are doing with respect to x, but right hand side you cannot do with respect to x. Therefore, you have to do with respect to t, then multiplied by dt by dx. What is dt by dx? It is 1 upon dx by dt. Very simple now. Substitute all of them which you are having with you. Substitute and you will get the final answer as secant cube t by 80. Go back to question number 15. It's a case study question. Now a graph was given and function is given to you. You have to discuss the continuity and differentiability of the given function. Therefore, first discuss the continuity. Continuity discussion means you have to prove for all real numbers, but we will try to prove for less than 1, add to 1, less than 2, 1 and 2, then less than 2 and greater than 2. Okay, well, now you can very quickly do it because at less than 1 it is a polynomial. For 1 to 2 it is a polynomial. For greater than 2 it is a polynomial. Therefore, no need to even discuss it, but I'm writing it so that it is a polynomial. Therefore, it is continuous. We have to check at 1 and 2. That is very clear. At x is equal to 1, as usual, f of 1 is given. We are finding the right limit. Right limit value is coming as 0. Let us go to the left limit. Left limit answer is also 0. And the functional value is also 0. Therefore, it is continuous at x is equal to 1. So the function is continuous. But be careful while you are taking the right limit. For right limit, x should be greater than 1. For left limit, x is less than 1. Accordingly, you have to select the function from the given function. Okay, well, now let us see the graph of it. We are seeing that at x is equal to 1, it is continuous. At x is equal to 1, it is continuous. We are seeing that it is continuously going over there. Okay, let us go to at x is equal to 2. As usual, f of 2 is 0. Right limit we are finding. Right limit is coming as 1. Left limit we are finding. Left limit is coming as 0. Therefore, right limit not equal to left limit. Therefore, not continuous at x is equal to 2. Now we are seeing over here at 2 there is a break in the curve. Therefore, it is not continuous at x is equal to 2. Let us check the differentiability at x is equal to 1 and 2. You know the formula. Limit x goes to 0, 1 plus h minus f of 1 by h. We have to put it there, right limit. Left limit you have to find. The right limit value is coming as minus 1. Be careful, at h goes to 0 plus means you have to take greater than and then you have to go for less than. Therefore, right limit, left limit I am substituting. You check out how that function is changing in 1 plus h and f of 1 plus h in both the cases. Well, therefore, you are getting the right limit and left limit as same. Therefore, it is differentiable at x is equal to 1. Let us check the differentiability x is equal to 2. And once again, the same idea. At x is equal to 2. 2 plus f of h goes to 2 plus. We are finding it. It is greater than 2. Therefore, we are taking that 3 minus x as the function. Therefore, the answer is infinity because denominator is 0. Now we are going to the left limit. In the left limit, then we are just checking it that it is going to 1. Therefore, left limit not equal to the right limit. Therefore, it is not differentiable at x is equal to 2 also. Thank you, friends. We will discuss the remaining questions in the next video.